After passing through the grade 12 past papers, I have discovered there are two concepts on an algebra which are always repeated. Even the exam you're going to sit for, these two concepts are going to appear. So why not watch this video to the end? What are those two concepts? Let's see if we can start with concept number one. Concept number one is very easy, and it's a linear expression. I'll write it, but before I can explain how to work with it, I need you to remember two principles that you have learned in school. And the first principle is a commutative law. What is this law? This law implies that if you have 2a plus b, these two applies both to the a and to the b. Meaning, to remove these brackets, we can do 2 times a to give us 2a. Then we drop this plus 2 times b to give us 2b. And just like that, we have applied the commutative law. So this means we can just distribute this now to this and to that. Some people can even refer to it as the distributive law. The second principle I need you to understand is this. Only add like terms. This is used when you are dealing with variables, because for variables you discover that sometimes we don't always have like terms. What do I mean? Let's say you have a b plus a plus 2a plus a b. In this situation, you ask yourself, what things are the same? AB and AB are the same. Then A and 2A are the same. I'm saying A and 2A are the same because 2A means here we have only one A, here we have two A's. Then these two are combined, they're making one thing as well. So to deal with this, I get A, B, and this A, B, I put them together. Then here, this A plus this 2A, and then I can go ahead and add them. AB plus AB. Think of this AB as one thing. AB plus AB means you have how many ABs? 2. So it's 2AB. Then A plus 2A. Apple plus 2 apples. That will give us 3 apples. Now here I have 2AB plus 3AB. Can I add these? No. AB and A are not like terms. So by like terms, I mean things that are exactly the same. These are not the same. So this expression ends there. Now let's attempt two examples. So the first example, Mathematics Grade 12 2025 paper written by the GCEs, paper 1. By the way, concept number 1 is found in the first paper, Mathematics paper 1. So the first question is saying simplify 2y minus 3, 2 minus y. How do you deal with this? So first of all, to bring it down here, 2y minus 3, 2 minus y. We use the distributive law or the commutative law, as in 2 times y, 2y, 2 times this 3 is going to give us a 6. Then we drop the minus. Then here, or you can look at it like this. Since this is 2, it's positive 2. So positive times negative is going to give us negative. This one, negative 3 times 2 is going to give us minus 6. And negative times negative will be positive. 3 times y, 3y. Now, after we have this, let's see if we can find the like terms. Second principle. So 2y and 2y are of course the same. So I'll write, 2y and 3y, 2y. Then I bring this, of course with its sign, the plus 3y. Then I drop the minus 6, then minus 6 here. 2y plus 3y. It's like 2 apples plus 3 apples. It's going to give us 5y or 5 apples. Then here, minus 6 minus 6. Minus 6 minus 6 is going to give us 12, like that. Where is minus 6 minus 6? How is it giving us minus 12? If we go to this, the number line, I will start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've just picked one side of the number line. This is the negative part, so that I can show you how that answer has come up if you do not understand. So looking at this, minus 6, minus 6. Think of this as the direction. Since the number line has two directions, that side has positive numbers, this side has negative numbers. So this sign is telling you to go in the negative direction by how many steps? 6. So starting from 0, I'm going to move 6 steps in this direction. 1, 2, 3, 4, 5, 6. Then I land here. Then which direction again? I continue in the negative direction. How many steps? 2 steps. So it means 6, so it's going to be 1, 2, 3, 4, 5, 6. And that's how come negative 12 is the answer. Example 2. So this is Mathematics Grade 12, 2024, Paper 1. Simplify 3 to x minus 4 and minus 2x minus 1. Again, I bring it down here. 3 to x minus 4, then minus 2x minus 1. Again, we use the same distributive law or commutative law. This times this gives me 6x, because 3 times 2 is 6. Then I drop the x like that. And 3 times this will give us the 12. Then here, negative 2 times this will be negative 2x. Negative times negative will be positive. 2 times this is 2. Then I collect my like terms, this with this, that with that. So this and that will be 6x minus 2x. Then this, I take it with its sign, minus 12 plus 2. Here, 6x minus 2x. Just think of it as 6 minus 2, which is obviously going to give us 4x. Then, negative 12 plus 2. For negative 12 plus 2, we are going to get negative 10. If you don't understand where negative 10 is coming from, use that method I showed you. Follow the steps. So, negative direction, 12 steps, then positive direction, 2 steps. You will land on negative 10. Example 3. So, Mathematics Grade 12, 2024 GCE Paper 1. So, 2024, same question, it always comes. This is a question that you are going to find in your exam, like I said before. So, simplify 4x minus 2 plus 3 2x minus 3. I'm begging you to pause the video, see if you can solve this, then compare with what I'm going to do. So let's get into this. This is 4x minus 2 plus 3 2x minus 3. Distributive law or commutative law again, 4 times this, 4x, 4 times this, minus 8. Then here, this times this will be plus 6x, because 3 times this is 6, then I drop the x. Then positive times positive is positive. Positive times this negative will be negative. 3 times this will be 9. Like terms, this and this, this and this. So here I have 4x plus 6x, then minus 8 minus 9. 4x plus 6x will be 10x. Minus 8 minus 9, it's like you are adding them, only they are going in the negative direction. You can use that number line method I showed you. So it's like 9 plus 8, which is obviously going to be 17. And just like that, we are done. Example 4. Mathematics grade 12, 2023, paper 1. So simplify this. As usual, 2a minus 5b, a minus b plus ab. Here, this is the only part where we have the brackets. This is the only part where we are going to use the commutative law. So this is going to be 2a as it is minus 5b times a will be minus 5ab. By the way, ab, ba, same thing. Then negative times negative will be positive. 5b times b will be 5b squared. B squared how? In mathematics, we don't say b. To simplify it, we write it as b with a 2. That 2 is showing us that we have 2 b's like that. So b squared means there are 2 b's there, plus a, b. Then here, the like terms. Which things are alike? Is there anything that a is common with? Is there anything that it looks like it? This is ab, this is b, this is ab. There isn't. Then ab and ab, so these are alike. Then this is 5b squared. It's not alike, or it's not similar to anything. So here, the only like terms I have are these 5ab and this plus ab plus 5b squared. Then this will be 2a minus 5ab plus ab. Think of AB as an apple. 5 apples plus 1 apple. Sorry, minus 5 apples plus 1 apple. Using that number line, it's like we'll be going 5 steps in the negative direction and then 1 step in the opposite direction. So this will be minus 4ab. Then the last part will be plus 5b squared. And just like that, we are finished. So these are the 4 examples I felt we could talk about. This concept is guaranteed you are going to find it in your exam. Let's go to concept number 2. Concept number 2 is found in paper 2. And for concept number 2, there are 2 concepts, 2 principles that I need you to understand before we can start solving. Principle number 1 is division of fractions. So 1, division fractions. Let's say you have 2 over 4 divided by, let's say 3 over 5. How do you solve that? Well, you take this part exactly as it is, 2 over 4. Then we change this division sign to a multiplication sign, and then we switch these. The bottom one goes up, or the denominator goes up. The top one goes down, or the numerator goes down. They switch places. So this will be 5 over 3. And then you just multiply them. 2 times 5, 10. 4 times 3, 12. The part I am interested in is what happens here. This changes to the multiplication sign, then these two switch, or they reciprocate. Second principle I need you to understand is this. Indices. So in indices, there are a lot of laws that they talk about, but the one thing I need you to understand is how they contract expressions. Let's say, for example, you have b times b times b times b times b. This can be contracted, can be written in a short form by counting the number of b's like this. 1, 2, 3, 4, 5. So we have how many? 5 b's. So we write the b itself and just put a 5 up there to show that there are 5 b's being multiplied by themselves. So b times b times b times b times b can be written in an easier, simpler way by just saying b to the power 5. Let's now solve the actual example. So this is a question that came in 2025 paper 2, and it looks like this. So for this one, the first step is for us to get rid of this division sign by using that first principle I gave you. So this is going to come as it is, this as it is, then we change this part, like this. So this is going to be a squared b to the power 3 over 2c multiplied by ac squared over 2b. Then this will become multiplication sign or the time sign. Then this bottom part will go top, this top part will go down. So this will be 2a over b squared c. After we have done this, then we can go ahead and multiply everything. So it will be this part times this part times this part. Then the bottom part, 2c times 2b times b squared c. So this will be a squared b to the power 3 times ac squared times 2a. The bottom part, 2c times 2b times b squared c. If you know what to do here, you can go ahead and just do this straightforward. Some people can even cancel from here. But to make sure you understand everything I'm teaching, I'm going to get this, put it there, expand it so you can see each and everything I am doing. So writing it here. Here. A squared means we have how many a's? 2. So this will be a times a. B to the power 3 means we have how many b's? 3. 1, 2, 3. Then multiplied by ac squared times, so this a is 1 times c squared means we have how many c's? 2. So this will be c times c, then times 2a. Now that it's expanded out, you can clearly see the individual letters like that. Then the bottom part, this will just be 2c, then 2b, then this b to the power 2 is b times b, then times c. After we have this, now we can cancel out the things that are appearing both the top and at the bottom. So these 2 cancels with that 2. Then do we have an a down here? No a. So these a's don't need to be cancelled. Then I have 1, 2, 3 b's, 1, 2, 3 b's. So this b, this b, this b with this b, this b with that b. Then what else do I have down here? I have c. Do I have c up here? Yes. This c with this c. Any other c, this c. So this c with this c. What do we now have? I have a. I have 4 a's on top. So a times a times a times a is a by a by a by a. Then at the bottom, what do I have? I have these 2. I only have a 2. Now if you remember from that second principle I taught you, a times a times a times a can be written as a to the power 4 over 2. And just like that, you are done with this one. Let's work on example 2. So example 2 looks like this. Again, as usual, we are going to get rid of this sign by taking everything, at least the first part, as it is. So this is 15 a squared b over 7c d squared. We change this the multiplication sign. The bottom part goes up, the top part comes down. So this will be 21c squared d to the power 3. Then this will be 5a 3b squared. Then bringing all this down here, this will be 15a squared b times 21c squared d3. Then the bottom part 7cd squared times 5a to the power 3, like that. Then when we take it there, I'm going to expand everything again so that we can see what we are doing. So this, when expanded, will be 15. A, we have a squared, so it's going to be times a, then times b. Everything multiplied by 21 times c squared is c times c. Then d to the power 3 is d times d, 3 d's. Then the bottom part, this would be 7 times c times the d's 2, everything multiplied by, then 5 times a times a times a, then times b times b, like that. Looks better like that. So when we have this, then we can look at the things that are common. So let's start with the numbers. 7, what number can go into 7 and 15? Nothing. But 7 and 21, 7 itself. So 7 into 7, 1. 7 into 21 is 3. Then C. Do we have a C up here? This C with this C. D. Do we have a D up here with this D, this D? D again, this D, that D. 5. 5 and 15. So 5 into 5 is 1. 5 into 15 is 3. Then A. This A with this A. This A with this A. Then this A, is there any other A? No. B, this B. So this B with this B. Then this B, is there another B up here? No. So now after this, let's see what has survived. We have 3 times 3 times C times D. Then at the bottom, 1 times 1 times this A times that B. So this 3 times 3 is 9 CD. Then 1 times 1 is 1, times A is A times this is A, B. Just like that, we are finished. Example 3. This time, I am no longer going to solve this slowly. We can now skip some steps because you understand what's going on. So as usual, we get rid of this part by taking this first part as it is, then over m squared, n squared. This becomes times, then on top, at the bottom, this is 2m squared, n squared, everything over 5a to the power 3. Now, even at this point, we don't even have to put them together. We can just say there's a number that can go into 5 and 10. So here, 1, this, 2. And then m squared cancels with m squared. N squared with n squared. Then a has nothing to cancel with. So what are we left with? The 2. On top, I have the 2 times what else? Nothing. Oh, sorry, these are the 2. Then here, nothing. This side, a to the power 3. So from here, you can clearly see that the answer will just be 2 times this, 4, a to the power 3. Let's go to number 4. Example 4. At this point, I expect you to pause the video, solve this by yourself. play, then compare with my answer. So as usual, we're getting rid of this by writing this as it is, 10 e to the power 3 q to the power 4 over 8 m to the power 4 n squared. This becomes multiplication sign, top, bottom, so this will be 4m to the power 4n squared over 25 e to the power 4 q to the power 3. So here I know 8 and 4. 4 into this is 1, 4 into this is 2. Then m to the power 4, m to the power 4, n squared, n squared. Then this side, 10 and 25. 5 into this is 2, 5 into this is 5. Then p to the power 3 and p to the power 4. Here I will remain with the p, because here I have 4 p's, here I have 3 p's. Then 4q squared and q to the power 3. Q to the power 4. Here I have 4 q's, here I have 3 q's. So this is going to be 1 q left over. This will completely cancel out. If you do not understand this, it's this. This will be 1, 2, 3, 4. Then this will be 1, 2, 3. This with this, this with this, this with this. I'll have 1 left over like that. So if we look at this, what has survived this? 2q. Here is just the 1. So 2q over down here 2 times 5, 10 and p. So this is just 10 p. And just like that, you are done with this. This concept, I'll say this once more, is guaranteed. It's going to come in the exam, and if you practice this well enough, finding it in the exam will give you that motivation you need, that motivation that's going to push you through the entire paper and get almost, if not everything, correct. Have a good day.